Okay, now I'm going to explain the washer method. The washer method is just basically the disk method with a little bit of a complication in it. So here's the region I want to rotate. It's bounded by the curves y equal to x, y equal to x squared. The axis of rotation is x equal to -1. Here's the y-axis, x-axis. This is the curve y equal to x. This is y equal to x squared. So that's the region that we have to rotate, and we have to rotate that, say, around x equal to -1. So this is -1. So this point goes here, that point goes about there. And that's the axis of rotation. So that's the volume. It's basically this quadratic bowl with a conical hole through it. So we follow the same procedure as before. We pick an S along the axis of rotation. We take a plane perpendicular to the axis of rotation passing through S. And we look at the cross section, and the cross section in this case will have an inner circle within which there is no material, and an outer circle, and in between these two circles is the stuff whose volume we want to calculate. And then, as before, we increase S to S plus ds. So if this was originally S, we increase its value slightly to S plus ds. Take a new plane at that value, slice through the volume, and now we get a new pair of circles. And this is complicated looking, so let me just draw the volume between those two slices down here. So at the top we have a pair of circles. At the bottom we have a pair of circles. And what we're interested in is the volume in between them. Here's the axis of rotation. And as before, the claim is that this thickness is just a small infinitesimal value ds. And when this is infinitesimal, the top and the bottom face look exactly the same. The area of the material in the faces is simply the area of the bigger circle minus the area of the smaller circle. So let me call the radius of the bigger circle r2, the radius of the smaller circle r1. Then the area of that face is pi r2 square minus r1 square. So that's just pi r2 square, the area of the bigger circle, minus pi r1 square, the area of the smaller circle. So the infinitesimal volume in between the top and the bottom is just dv equals area of the face, which is pi r2 square minus r1 square times ds. And as before, the volume v is the integral from the lower limit of s to the upper limit of s of pi r2 square minus r1 square ds. And all we have to do now is to figure out how r2 and r1 are a function of s. And that's the only complication, that's the only difference between this and the disk method, is that now we have to go back and not just figure out the equations for where the upper circle touches the region, but where the outer circle touches the region, but also where the inner circle touches the region. So for this problem, I'm going to do that in the next video.